Ever went to shake your friend's hand only to get shocked? Or maybe you were sitting down on a nice rainy day only to get absolutely terrified at the loud sound of a lightning strike hitting the ground. Well, what if I told you that both of these phenomena are based on the same fundamental concept, which is static electricity? Now, in order to understand this phenomenon, we first have to take a look at the composition of an atom. Now, an atom consists of three main parts. The first are electrons, which are negatively charged, protons, which are positively charged, and neutrons, which carry no charge and which we won't be discussing in this video. Now, both the neutrons and protons reside in the core of the atom, while electrons orbit them. Now, generally, an atom will contain the same amount of protons as electrons, making it overall neutral. But in some cases, an atom can be susceptible to losing some of its outermost electrons if they are loosely bound to the core, while other atoms can be susceptible to gaining these electrons. So by having these two atoms interacting with each other, either through friction or in some cases just touching, electrons can move from one atom to the other, aka static charge. This transferring of electrons can cause an imbalance in the distribution of charges. So while the overall number of positive and negative charges is the same as before, their distribution isn't. Now, in nature, almost everything tends to equilibrium. So whenever a charged object, say a human being, goes to touch a large conductive surface, or just another object with an abundance of opposite charge, a sort of neutralizing effect takes place where electrons rush from one object to the other. This is what's called as electrostatic discharge and can be extremely painful due to the stimulation of nerve endings located on the skin. But what can be considered as nothing more than a nuisance at home can quickly become a very dangerous and even deadly phenomena outside. I'm of course talking about lightning, as it too is based on the same concept. Now, while scientists aren't quite sure as to how it forms, a theory suggests that it's due to the heavier particles inside of the cloud that are falling down, colliding with the ice crystals going up. This causes a transfer of electrons from the ice crystals to the heavier particles, which in turn causes the bottom of the cloud to become negatively charged. These negative charges then get released to the ground in the form of lightning. An experiment that you can do at home and that can demonstrate some of the other effects of this force goes as follows. Get a balloon and fill it up with air. Tie it up and then rub it on someone's hair. What this does is it makes the loose electrons in your hair move over to the balloon, making it negatively charged. Then, by approaching this charged balloon to some scraps of paper, we can observe its effect. Now that you know about the basics of static electricity, you can impress your friends with your newly acquired knowledge and teach them too about the amazing world we live in.